Yes, welcome to example 2.12. Here we are asked to prove Blondel's theorem. Blondel's theorem. This is a load that is connected in a delta fashion. Delta. Right. And we are asked to prove Blondel's theorem with this. So to prove Blondel's theorem, what we need to do is we want to determine if the total power in these phases PAB, PBC, and PCA added together is equal to the total power measured by these wattmeters on lines A and C. So if we measure the two wattmeters reading here on A and C, if they equal to the total power consumed by this load, PAB, PBC, and PCA, then our Blondel's theorem is proved. And how do we do that? Let us try to start with drawing the phasor diagram. They said it's a positive phase sequence with EAC as a reference. EAC at angle 0. If EAC is at 0, then ECA will be at angle 180 degrees. Right. Then from there, you can now establish your the positioning of other phasor elements. EAB then will be here because it's a positive phase sequence at angle 60 degrees. EBC will be here at angle minus 60 degrees. Then from there, you can now to be able to get PAB. PAB is supposed to be what? The voltage across VAB and IAB, because VAB, IAB. So the very first thing you want to do is to determine what is IAB there. Our VAB is at angle 60. Our IAB will be VAB by ZAB. And what is our VAB? The voltage given is 480 volts, then at angle 60 degrees. So that gives us what? Divided by the ZAB. Our ZAB is given as 23 at angle 39 degrees. That is our IAB, which eventually gives us 20.87 at angle 21 degrees amps. So we have our IAB. So if you want to determine our VAB now, our PAB then will be what? VAB, which is 480 times IAB, which is 20.87, cos the angle of VAB is 60 degrees minus the angle of IAB, which is minus 21 degrees. So that will eventually give us what our PAB is. So our PAB from there will give us 7,785.137 watts. So that's our PAB. So now we need to find our PBC. We have determined our PAB. Our PAB is equal to our PAB is equal to 77,785.135 watts. So we want our PBC. Our PBC, this our PAB is 77,785.135. So our PBC is what? VBC IBC cos VBC IBC. So the first thing is we have to find our IBC. Our IBC VBC divided by ZBC, right? And what is our VBC from the Professor? It is 480 at angle minus 60 degrees. So divided by what? Divided by ZBC. What is our ZBC? Our ZBC is 29 at angle minus 34. 29 at angle minus 34 degrees. So when you find that one out, you get 16.552 at angle minus 26 degrees amps. So that is our IBC. So having determined our IBC, we can now find our PBC. Our PBC will now be VBC, which is 480 times IBC, which is 16.552, because the angle of VBC is minus 60 degrees minus the angle of IBC, which is minus 26 degrees. So that gives us what? It gives us 6586.67 watts. So that is our PBC. So our PBC is equal to what? 86.67 watts. So that is our PBC. So we have our PBC. So now the next thing we want to find is our PCA. Our PCA, which is this, our PCA is also going to be what? VCA ICA cos VCA ICA. Right. So what is our ICA? Our ICA is VCA by ZCA. Our VCA is given as at angle 180. That is what? That is 480, which is the voltage given in the question. 480 at angle 180 degrees divided by ZCA. What is our ZCA? 19 at angle 64 degrees. So what does that give us? It gives us 25.263, right? At what angle? Angle 116 degrees amps. So that is our ICA. So from there we can now find our PCA, which is 480 times ICA 25.263, cos the angle of VCA, which is 180, minus the angle of ICA, which is minus 116 degrees. So that gives us what? 5,336.836 watt. So that is our PCA. So our PCA is equal to what? It's equal to 5,336.836 watts. So we have found all the power consumed by all the loads in the three phases. So now we need to find what is the power in measured by WA. WA, to be able to measure power in WA, we need to know what is our IA, the current flowing in that wattmeter, and we need to know IC. So our IA is equal to, this is IAB, and this is ICA. So our IA will be what? Will be IAB minus ICA. IAB minus ICA. So when you and we already found our IAB and we found our ICA. Once you subtract your IAB that you found, your ICA from IAB, once you found it, you find it to be 34.142 at angle minus 26.49 degrees amps. Then you go ahead and find your IC also. IC also, which is the current flowing here, which will be what? ICA minus IBC, because IBC is the current flowing here. So once you find, you already calculated ICA and IBC, so once you subtract them from each other, you get 39.638 at angle 130.9 degrees amps. That is your IC. Then from there, you can now find the wattmeter reading. So the wattmeter reading of A will be V, the voltage here, across the wattmeter reading, across the wattmeter A, this is VAB. So it will be VAB times IA cos VAB IA. So what is our VAB? Our VAB is at angle 60, that's 480 times our IA. Our IA is 34.142 cos the angle of VA is 60 degrees minus the angle of IA is minus 26.49 degrees. So when you find that one out, what do you get? You get 1.003 kilowatts. So this one will give you 1.003 kilowatt. 1.003 kilowatt, that is WA. So now we need to find WC. WC, the wattmeter reading in WC also will be what? This is the voltage across here, which is VCB, right? So that means you have VCB times IC cos VCB IC. So our VCB, if this is VBC, right? Our VCB then will be across here, which will be what? That is, you look, this will be at angle 120 degrees. That is our VCB. So that means our VCB will be 480 times IC, which is 39.638 cos 120 degrees minus 130 degrees, 130.9 degrees. So that will give you what? 18.63683 kilowatt. So that is the wattmeter reading on C, which is what? 18.683 kilowatts. So now the next thing now is you want to check if they are equal to each other. So when you look at, when you had all PAB, P total, PAB, PBC, and PCA together, when you add them together, you will discover that they are now equal to the wattmeter reading, which is WA plus WC, because WA plus WC gives you what? 19.686 watts, right? And if you had all the power in the load together, it gives you what? 19.71 kilowatt, of course, which is approximately equal. So that shows that Blundett's theorem is proved. That means your P total is equal to your W total. Blundett's theorem proved. Thank you.